Good evening, children.
Good evening, ma'am.
Good evening. Yes, children. Write on this question. Prove the following identity. Sin theta to the power 8 minus cos theta to the power 8 is equal to sin square theta minus cos square theta into 1 minus 2 sin square theta cos square theta. Please write down. Done, children? All right. So see the proof here. So this is what we are given in the left-hand side. Sin theta to the power 8 minus cos theta to the power 8. Now 8 is 4 into 2. 8 is 4 into 2. And you can see the minus sign here. It is sin theta to the power 8 minus cos theta to the power 8. There's a minus sign here. Now we have this identity a square minus b square, which is a plus b into a minus b. Okay. So 8 is equal to 4 into 2. And we choose to, we choose to put the 2 outside so that the expression looks like a square minus b square. See here? So 4 2s are 8. See, you can switch the places also. You can put 2 here and 4 here. No, but we're not doing that because we want the expression to look like a square minus b square so that it can be further factorized as a plus b into a minus b. All right, so we choose to write 4 inside the bracket and 2 outside the bracket. So see here, sin theta to the power 4 the whole square minus cos theta to the power 4 the whole square. We put the 2 outside. 4 2s are 8. There's a minus here. We put the 2 outside. So now this is of the form a square minus b square, which is a plus b into a minus b. See here, this is a. See here, this is a square minus, this one is b. This one is b square. So a is sin theta to the power 4 and b is cos theta to the power 4. A square minus b square is a plus b into a minus b. So sin theta to the power 4 plus cos theta to the power 4 into sin theta to the power 4 minus cos theta to the power 4. This is a, this is b. A plus b into a minus b. That is the first step. Okay. Now, this, see the minus sign here? See the minus sign here? So this can further be written in the form a square minus b square. This can further be written in the form a square minus b square. So let's talk about this bracket. So this can be written as sin square theta the whole square minus cos square theta the whole square. All right, because 2 2s are 4. 2 2s are 4. So now, again, it's in the form a square minus b square, but this time a is sin square theta and b is cos square theta. See, this is a square minus, this is b square. So this time a is sin square theta. This time a is sin square theta and b is cos square theta. B is cos square theta. So here, this one children, this one children. All right. So it's a plus b. A plus B into A minus B. Okay, I think I made some mistake in the next one. I've forgotten to type that. Sorry. Sorry, children. Yeah. All right. So here it should be. It should be A. This is A plus B. This is plus B. All right. Into A. This is A minus B. Minus B. This one. I've forgotten to type that. All right. So this is about the first bracket, children. The second bracket I've forgotten to type. This is about the first bracket. See the second bracket here. See, I was talking about this one. A square minus B square. Okay, it's A plus B into A minus B. Can you see here? A plus B. I told you this time A is sine square theta and B is cos square theta. All right. So A plus B, sine square theta plus cos square theta into A minus B, sine square theta minus cos square theta. And now we know that A square minus, sine square theta plus cos square theta is 1. And 1 into, see, this is 1. This is 1. And 1 into sine square theta minus cos square theta, which is sine square theta minus cos square theta. Which is sine square theta minus cos square theta. All right, so let me do that here. All right. So we're done with the second bracket, children. We are done with the second bracket. See here, we started like this. I think till here it should be clear. Sine theta to the power 4 minus cos theta to the power 4 is again written in the form A square minus B square, sine square theta the whole square minus cos square theta the whole square. So A plus B, see here, sine square theta plus cos square theta into A minus B, sine square theta minus cos square theta. So what will happen the next step? Sine square theta plus cos square theta is 1. 1 into sine square theta minus cos square theta is sine square theta minus cos square theta. This is about the second bracket. Now come back to the first bracket, this one. This is the first bracket. All right, this is the first bracket. Now this is in the form, you should show that this is in the form A square plus B square. That's all you can do. You cannot do anything else because 4 can be further written as 2 into 2. So this is sine square theta the whole square plus cos square theta the whole square. So this is of the form A square plus B square. A square plus B square. A square plus B square is A plus B the whole square minus 2AB. We saw this in the last class. We saw this in the last class. Okay, so how do we get that? A square plus B square plus 2AB is A plus B the whole square. A square plus B square plus 2AB is A plus B the whole square. So A square plus B square is equal to A plus B the whole square minus 2AB. So we write, so now this is of the form A square plus B square. A square plus B square, where A is sine square theta and B is cos square theta. So A square plus B square is A plus B the whole square. See here, A plus B the whole square minus 2AB minus 2 sine square theta cos square theta. Now here sine square theta plus cos square theta is 1. 1 square is 1. 1 square is 1. 1 minus 2 sine square theta cos square theta. I don't know. I've just messed up everything here. I'll better write it for you, children. We're actually done with the proof. I don't know what I've done here. Let me just work this for you. Yeah. Yeah, I think you can now start working, children, with me. Yeah. So we take up the LHS, or you can just listen again. So this is what is in the left-hand side. First step, sine theta to the power 4, the whole square. Put the square outside. Cos theta to the power 4, whole square. Put the square outside. So A square minus B square, which is A plus B. This is A. This is A plus B. This is plus B into A. This is A minus B. This is minus B. Okay, this is the first step. Now write the first bracket as sine square theta, because 4 is 2 into 2. So sine square theta, the whole square, plus cos square theta, the whole square. Second bracket as sine square theta, the whole square, minus cos square theta, the whole square. All right. Now the first bracket is of the form a square plus b square, which is a plus b, the whole square. This is a plus, this is b, the whole square, minus 2ab, minus 2 sine square theta, cos square theta. Okay, this is about the first bracket. A square plus b square is a plus b, the whole square, minus 2ab. And the second bracket, I'm writing it below, children. The second bracket, which is a square minus b square, is a plus b into a minus b. A plus b into a minus b, All right. Now, the first bracket. Okay. So sine square theta plus cos square theta, the whole square. Sine square theta plus cos square theta is 1. So 1 square minus 2 sine square theta, cos square theta. And in the second bracket, again, sine square theta plus cos square theta is 1 into sine square theta minus cos square theta. So now 1 square is 1 minus 2 sine square theta, cos square theta. And in the second bracket, we have 1 into anything is the same thing. So sine square theta minus cos square theta, sine square theta minus cos square theta, which is the RHS. You can see the RHS is the same. Please write down, children. Yes, children. This is the next one. All right. So here, take up the LHS. LHS. This is the LHS, children. We know that 1 by tan square A is cot square A, and 1 by cot square A is tan square A. 1 by tan square A is cot square A. 1 by cot square A is tan square A. So we have 1 plus cot square A into 1 plus tan square A. And again, by the identity, 1 plus cot square A is cosecant square A. And 1 plus tan square A is secant square A. But look at the RHS. It's 1 by sine square A minus sine A to the power 4. All right. So cosecant square A is 1 by sine square A. Cosecant square A is 1 by sine square A, reciprocal ratios. Secant square A is 1 by cos square A. All right. So 1 by sine square A into 1 by cos square A. So multiply the numerators, 1 into 1, 1. Multiply the denominator, sine square A into cos square A, sine square A, cos square A. But again, that's not the RHS. In the RHS, we don't have cos at all. We don't have cos. We only have sine. So you need to remove. You need to get rid of cos square A. You need to get rid of cos square A and introduce sine square A. Something in sine, whether sine square A, whatever. You need to get rid of cos square A and replace that using sine. So we know that cos square A is 1 minus sine square A, identity. Sine square A plus cos square A is 1. So we know cos square A is 1 minus sine square A. So sine square A into, instead of cos square A, see here, this is sine square A into cos square A. So sine square A in the bracket into cos square A is 1 minus sine square A. Now multiply sine square A into 1 is sine square A. Sine square A into sine square A is sine A to the power 4. 2 to the 4. Write down, children. Please write down. Done, children?
Yes, ma'am.
All right. Yeah. So this also, children. Very simple because see here, 1, see here, 1, 2, 3, 4. There are 4 terms. See here, sine square A cos square B plus cos square A sine square B plus cos square A cos square B plus sine square A sine square B. So in the left hand side, we have 4 terms. We have an expression made up of 4 terms. And remember, whenever we have 4 terms, we'll try to group. We'll group, meaning we'll find something common between the first 2 terms. We'll find something common between the third and the fourth terms and proceed. Supposing the first and the second term, the third and the fourth terms, they don't have anything in common, then try to rearrange. Put the third term in the second position, take the second term to the third position. So just switch the places of the terms and then see if there's anything common. So just doing that, you can prove this identity, children. I have the answer. Let me just explain using this. So you can see here, sine square A, cos square B, cos square A, sine square B. Now, is there anything common between these two? Sine square A, cos square B, cos square A, sine square B. There's nothing common. See, a sine square A, this is sine square B. This is cos square B, this is cos square A. There's nothing common. So we first write the LHS as it is given, as it is given. See, this is the LHS as it is given. This is the left-hand side as it is given in the identity. So now, since there's nothing common between the first two terms, we rearrange. You can bring any term, children. Just that the first and the second, the third and the fourth, they should have something common. So see here, I've written the first term as it is sine square A cos square B, and I have moved the third term, cos square A cos square B here. I moved this third term to the second position and the second term to the third position. So this one cos square A cos square B comes here to take the second position, and cos square A sine square B in the second place goes to the third place, cos square A sine square B. And the last term as it is sine square A sine square B. We just rearrange. That's what we normally do. While this is in algebra, it is factorizing by grouping. In algebra, it is factorizing by grouping. So normally there we have 4, we can have 6 terms also, but normally we have in 8th standard level, we normally have 4 terms. And, to factorize by grouping, you will have to find something common between the first and second term, common between the third and fourth term. But if there's nothing common, then rearrange. So that's what we've done now, rearrange. Now, what's common between the first and second term? The first and the second term, what's common? See here, cos square B is common. Cos square B is common. Bring it out. So sine square A and cos square A in the bracket. Sine square A and cos square A in the bracket. Now between the third and the fourth term, sine square B is common. Sine square B is common. So out cos square A plus sine square A in the bracket. In the bracket. All right. Now cos square B as it is, we know this is 1. Sine square A plus cos square A is 1 into 1. And this is also 1. So there's nothing but cos square B plus sine square B. Again, identity. Again, it's an identity. Sine square B plus cos square B is 1, which is the RHS. Write down. Please write down. Done, children?
Yes, ma'am.
Yeah. All of you?
Yeah, ma'am.
Yes, ma'am. All right. Yeah, so see this one. We saw this, this we have done from NCERT, a similar one. Yeah. So take up the LHS. This is the LHS. Write on the LHS here. Now, first, because they look like a minus b the whole square, here also x minus y the whole square, expand using the identity. Expand using the identity. You can see here, the RHS is 1 minus secant A cosecant A. See here, you have secant A, cosecant A here. The RHS also has secant A and cosecant A. 1 minus secant A, cosecant A, the whole square. All right. So first, this is a minus b the whole square, and this is a minus, sorry, x minus y the whole square. All right. So let's expand using the identity. So the first bracket, it's going to be a square plus b square minus 2ab. A square sine square a plus b square plus secant square a minus 2ab minus 2 sine a secant a plus the connecting sign plus this is like x minus y the whole square. So x square cos square a plus y square plus cosecant square a minus 2xy minus cos a cosecant a minus cos a cosecant a. Now, after expanding, you'll have to do one very important step. See, the RHS is like is something like, you know, m minus n the whole square. So that means to get this RHS, you need three terms. You need these three terms, m square minus 2mn plus n square. Look at the RHS. It's 1 minus secant A cosecant A the whole square. So if you have to get something like this, m minus n the whole square, you need to have three terms, m square minus 2mn plus n square. If you have these three terms, m square minus 2mn plus n square, then you can write this as m minus n the whole square. So now after expanding, we have six terms. After expanding, we have six terms, 1, 2, 3, 4, 5, and 6. Now we're going to group, these six terms in twos. How? See here, group sine square A, cos square A. I'll tell you why. I'll tell you why. Group sine square A and cos square A. See here, sine square A plus cos square A. Then group the terms that have 2 in them. See here, this minus 2 sine A secant A, minus 2 cos A cosecant A. Group that. See here, minus 2 sine A secant A, minus 2 cos A cosecant A. And then the leftover. Secant square A and cosecant square A. Secant square A, cosecant square A. See here, secant A, cosecant A. Secant A, cosecant A. So you'll have to group secant square A and cosecant square A. And this is 1. How do you get 1? Sine square A plus cos square A is 1. Sine square A plus cos square A is 1. So it's very easy to group. So how do you group? After expanding, group sine square A and cos square A. Put them in one bracket. And then this one, these two terms which have 2 in them, minus 2, minus 2. Minus 2, minus 2. So minus 2 sine A and secant A is 1 by cos A. And this one, minus 2 cos A and cosecant A is 1 by sine A. And the leftover, plus secant square A and plus cosecant square A. Now, sine square A plus cos square A is 1. Here itself you can write, children. See, here itself you can write 1 by, if you want, you can write 1 by cos square A and 1 by sine square A. Here also, here itself. All right. So next, sine square A plus cos square A is 1. 2 is common here. Whenever there's something common, we bring it out. So 2 is common, out, 2 common. So you get sine A by cos A, because sine A by cos A, and minus cos A by sine A. Sorry, there's a minus outside. So minus into plus is minus. Minus into plus is minus cos A by sine A. This one is 1. Minus 2 common. So sine A by cos A. Minus into plus is minus cos A by sine A. Close the bracket. Plus group these two terms. 1 by cos square A plus 1 by sine square A. Now, here we have to take the LCM. Cos A sine A, So sin A cos A is a common denominator. Numerator, you will get sin square A plus cos square A. Sin square A plus cos square A. That's about this bracket. Sin A cos A is a common denominator. Sin square A plus cos square A. Here also, common denominator sin square A cos square A. Numerator, you will get sin square A plus cos square A. Sin square A plus cos square A. So that's about this step, taking the common denominator. So 1 minus, now you know that sin square A plus cos square A is 1. This is 1. This one is 1. So it will be 2 by sin A cos A. 2 by sin A cos A. And this one is 1. Sin square A plus cos square A is 1. 1 by sin square A cos square A. 1 by sin square A cos square A. So now what are the terms you need to get here, children? You need to get 1 minus 2 secant A cosecant A. All right. 1 minus 2 secant A cosecant A plus secant square A cosecant square A. This is what you need to get. You need to get 1 minus 2 secant A cosecant A plus secant square A minus cosecant square A. Plus secant square A cosecant square A. Because these three terms will make a 1 minus secant A cosecant A the whole square. So see here, 1 minus sin A when it goes up to the numerator, it becomes cosecant A. Sin A when it goes up to the numerator, it becomes cosecant A. And cos A becomes secant A. Because it's like 1 by sin A. 1 by sin A, which is cosecant A. 1 by cos A, which is secant A. Here also, 1 by sin square A, 1 by cos square A. So 1 by sin square A is cosecant square A, 1 by cos square A is secant square A. So now we have got those three terms. Now we have got those three terms. 1 minus 2 cosecant A secant A and plus cosecant square A secant square A. So see here, A square minus 2AB plus B square. A square minus 2AB plus B square, which is A minus B the whole square, which is the RHS. Children, this answer, I just want to do some corrections in the presentation. So don't write on this, leave some space. I just want to make some small corrections. That's correct, this one, but I just want to make some small corrections on this working here. So don't write on this one. I'll share the picture later. I'll correct this and share the picture later. So first it's like expand this. So you get 3 terms. You get 3 terms. Expand this one, you get 3 more terms. Then you'll have to group. How? Sin square A and cos square A. Obviously, that makes an identity. Okay. Then these 2 terms which have 2 in them. Minus 2 and minus 2, these 2 terms. And then whatever's left, secant square A and cosecant square A. So gather them like that. Okay. And after that, this one is 1. So here, you write secant A as 1 by cos A. Cosecant square A is, where is it? Yeah, secant A is 1 by cos A. Cosecant A is 1 by sin A. And then you also write secant square A as 1 by cos square A and cosecant square A as 1 by sin square A. Then common denominator. Then all this becomes 1, this becomes 1, this becomes 1. So then you come here. 1 by sin A is cosecant A, 1 by cos A is secant A. And 1 by sin square A is cosecant square A, 1 by cos square A is secant square A. So now you get those 3 terms. Needed to make this 1 minus secant A cosecant A the whole square. The 3 terms, A square minus 2AB plus B square, which is A minus B the whole square. Just leave some space for this, children. It's a small notebook, probably some 2 pages. Long notebook, probably 3/4 of a page. Leave sufficient space. We'll do this later. See this one, children. So you can see the RHS, but the LHS and RHS, they have the same ratios. Tan A, cosecant B, cot B, secant A, cosecant A. This is cosecant B, but here it's cosecant A. This is secant A, this is secant B. Okay, so tan and cot are the same. Tan A, cot B. So tan A, cot B. Cosecant B, secant A, but here it is cosecant A, secant B. Okay. All right. So take up the LHS. Take up the LHS, expand. That's the first step. Expand. Expanding is the first step. Then since there's a minus here, children, there's a minus here. So all these terms will come out with the opposite sign. So minus cot square B, minus secant square A, minus into minus plus 2 cot B, secant A. This is just expanding. After that, be careful when you open the bracket, apply the minus sign to every term in the bracket. Okay, so that is the step. That is the step. Now, see here, tan square A. Can you see the 4 terms, children? Can you see tan square A, cot square B minus cot square B, secant, see these 4 terms, tan square A, cosecant square B, cot square B, secant square A. See these 4 terms. So you know that tan square A and secant square A, they are related through an identity. So I've gathered them, tan square A and secant square A. Then this cosecant square B and cot square B, cosecant square B minus cot square B. And then the remaining 2 terms, 2 tan A cosecant B and this plus 2 cot A secant A, cot B secant A. So first step is about expanding. The second step is about applying the minus sign to every term inside the bracket. The third step, how to gather here, tan square A and secant square A, cosecant square B and cot square B. And then these 2 terms, which have 2 in them, 2 tan A cosecant B, 2 cot B secant A. Okay. Now we know that cosecant square theta minus cot square theta is 1. So 1 you get here. See here, 1. So we know that this one is 1. Cosecant square B minus cot square B. Cosecant square theta minus cot square theta is 1. And here, children, this is tan square A minus secant square A. Tan square A minus secant square A. Secant square A minus tan square A is 1. Secant square theta minus tan square theta is 1. Then tan square theta minus secant square theta will be minus 1. If you want, so I have written minus 1 straight away. I can tell you, I can give you one more step for that. I can give you one more step for that. See here. What I'm saying is if secant square theta minus tan square theta is 1, then tan square theta minus secant square theta should be minus 1. If this is not clear, you can just put one extra step. So see here, you can just take away tan square A. What is tan square theta? What is tan square theta? Secant square theta minus 1. So you can put here secant square A minus 1 minus secant square A. See here, take away in the next step, take away this tan square A and write that as secant square A minus 1. Then this minus secant square A. So minus secant square A plus secant square A gets cancelled and see you're left with minus 1. That's what I've written straight away. This cosecant square B minus cot square B is 1, children. That is 1. Here we have tan square A minus secant square A. So what you can do is you can remove this tan square A, and we know that tan square A is secant square A minus 1. Minus secant square A. So this plus secant square A minus secant square A gets cancelled. So minus 1. See here, minus 1, minus 1. So this one is minus 1. This tan square A minus secant square A is minus 1. Cosecant square B minus cot square B is plus 1. And then we have these 2 terms. And then we have these 2 terms. Now, children, look at this one. Minus 1 plus 1 gets cancelled. So you're basically left with these 2 terms. See, this is minus 1, children. This is minus 1. This one is plus 1. This one is plus 1. So minus 1 plus 1, 0. So basically you're left with these 2 terms. We expanded. Then we applied the minus sign to all the terms in this bracket. That's this step. And here we gathered tan square A, secant square A. which is -1. Cosecant square B minus cot square B, which is 1. -1 plus 1 is 0. So you're basically left with these two terms. Okay, so there, look at the RHS, children. What have they taken common? 2 tan A cot B. You also take out the same thing common. There's actually 2 tan A cot B is not common. See here, actually 2 tan A cot B is not common. You can see here, 2 tan A cot B. It's not common. It's not common between these two terms. Between these two terms, 2 tan A cot B is not common. But the RHS, you can see here, 2 tan A cot B. So you're forced to take that common. I can give you an example before I explain this. Now, supposing you have, say, 2AB plus 2CD, children. All right. Supposing you have 2AB plus 2CD, and I take out 2AC common. Is that possible? It's a different slide. Huh? Okay, yeah. Now, supposing you have 2AB plus 2CD. Now, what is actually common between these two terms? Only 2. But I am taking out 2AC common. 2 is common, but AC is not common. But I'm taking out 2AC common. Now, in the bracket, what should we write? Now, 2AC. Actually, 2AC is not common. Only 2 is common. All right. Now you need to get this first term 2AB. 2AB. 2A is outside. So actually you should put B here. Listen very carefully. Let me start again. We have 2AB plus 2CD. What is common? 2 is common. But I am taking 2AC as common. Open a bracket. What should be the product? 2AB. We have 2A outside. We have 2A outside. So 2A into B is 2AB. 2A into B is 2AB. No, but we'll get 2ABC. You get 2ABC. What's the product? 2ABC. But what should you actually get? You should get only 2AB. 2A and B. The C is extra. So divide by C. So what will happen? The C and C will get cancelled. And the product is, now what is 2AC into B by C? CC cancels 2AB. 2AB. Similarly, plus the product should be 2CD. We have 2C. So I'll put a D. So I'll get 2CD. But actually, you'll get A extra. You'll get 2ACD. No, it's only 2CD. It's not 2ACD. It's only 2CD. So divide by A. So what will happen? 2AC into D by A. 2AC into D by A. A cancels. So 2CD. We'll take something else common now. 2BD common. Open bracket. The first term is 2AB. So 2A. When you multiply 2BD into A, you will get 2ABD. Actually, you should get only 2AB. D you should not get. So you should divide by D. Then D and D will get cancelled. So divide by D. Divide by D. So what will happen? D and D will get cancelled and the product is 2AB. 2AB. Plus, you need to get the product as 2CD. 2D is there. So you should put a C here. This B you don't need. You'll actually get, when you multiply 2BD and C, you will get 2BCD. But actually you should get only 2CD. You need to get only 2CD. So divide by B. So divide by B. So what will happen when you multiply 2BD and C by B? B and B will get cancelled. The product is 2CD. We'll apply the same, the idea here. Now this is gone, children. -1 plus 1. This is gone. -1 plus 1, 0. We have only these. These two terms. Now you can see here 2 tan A cot B is common. So even we take out 2 tan A cot B common. 2 tan A cot B common. Now 2 tan A cot B, 2 tan A, see here. 2 tan A. There is no cot B in the first term. So divide by cot B. You have 2 tan A cot B outside. You have 2 tan A cot B outside. But the first term here has only 2 tan A. It does not have cot B. So divide by cot B. And you need what cosecant B. Put that in the numerator. So 2 tan, when you multiply cot B and cot B will get cancelled. 2 tan A cosecant B. 2 tan A cosecant B. This is 2 cot B secant A. 2 cot B secant A. So 2 cot B. So I'll have to put a secant A here. So when you multiply, you'll get 2 cot B secant A. You don't need tan A. So divide by tan A. This one is 2 cot B secant A. 2 cot B. So put a secant A in the numerator. We don't need tan A. So divide by tan A. So when you multiply, what happens? When you multiply 2 tan A cot B and secant A by tan A, what happens? Tan A and tan A gets cancelled. So the product is 2 cot B secant A. 2 cot B secant A. So though tan A cot B is not common, we take it out because the RHS looks like that. Okay. Now after this, again, we have not got the RHS. We haven't got it. All right. So to continue, 2 tan A cot B. Now you need to get only cosecant A and secant B. But you don't see cosecant A is not there at all. Secant B is also not there. You don't see that here at all. All right. So 2 tan A cot B. This one, children, 2 tan A cot B here. 2 tan A cot B. Now cosecant B. Cosecant B can be written as 1 by sine B. 1 by sine B. The numerator cosecant B is 1 by sine B divided by what is cot B? Cos B by sine B. Cos B. See, this is cosecant B. See, this is cosecant B divided by this is cot B. This is cot B. Cot. This is cosecant B, which is 1 by sine B divided by this is cot B. Cos B by sine B. Next plus. So plus secant A, which is 1 by cos A divided by tan A, which is sin A by cos A, sin A by cos A. That's the next step. Because we have not still got the RHS. RHS is cosecant A, but this is cosecant B. So we have to do something. What can you do? So change them to sin and cos. Now, so 2 tan A cot B as it is, 1 by sin B, division becomes multiplication and reciprocal, sin B by cos B. Here also the same thing, division becomes multiplication, reciprocal, cos A by sin A. Now this one as it is, so sin B cancels, so 1 by cos B you get, 1 by cos B. See, sin B cancels, 1 by cos B, which is secant B. And here cos A gets cancelled, 1 by sin A, which is cosecant A. 1 by sin A, which is cosecant A, which is the RHS. Which is the RHS. Important, children, please write down. Class, use the emoji. Raise your hand. Ramnathan, Shreyas, Harini, Sneha, Priyanka, Ananya, Nandini, Netra, Rajarajeshwari. What about Hitesh, Murali, and Sashmin? Hitesh. Murali is there. Hitesh and Sashmin, I hope you're there in the meeting. Meaning you're there in the meeting. I hope both of you are in front of the device, listening carefully. Yes, children, please write down. Finish writing, children. Okay. Done, children?
No, ma'am.
Okay, sorry. Done? Okay. All of you?
Yes, ma'am.
Yes, children, please write down. So again, the same heading, prove this identity. Cos square A by 1 minus tan A. Let me make it theta. 1 minute. Right, so it's cos square theta divided by 1 minus tan theta plus sine cube theta divided by sine theta minus cos theta is equal to 1 plus sine theta cos theta. Sine cube theta, sine theta minus cos. Yeah. Yes, children. Tell me. Shall we write cos square theta as it is? Shall we write cos square theta as it is, children? No, no, no. See, well, you don't have to change sine to cos when you start off, because you see you're okay with sine and cos. There is no partiality between sine and cos. Both are equally, meaning they're given equal weightage. So nothing that sine theta is superior or cos theta is superior. So if we have other ratios, we'll convert that to sine and cos. But if it is cos, let it be cos. It's not going to be any better by converting it to sine. Unless otherwise needed. See, if you're in the last stage of the proof and you see that the RHS does not have cos theta at all, then you can write it in terms of sine theta. But now you don't have to do that. Now we don't have to do. As soon as we start, you don't have to write cos square theta is 1 minus sine square theta. You don't have to do that. So we know that we are fine with cos theta and sine theta. Cos and sine. So we'll write cos square theta as it is. If we have other ratios, we're going to convert that to sine and cos. But sine cos is fine. So 1 minus tan theta sine theta by cos theta. Tan theta sine theta by cos theta plus here everything is fine. So we're going to write it as it is. So in simple words, we write tan theta alone because the others are sine and cos. So we write tan theta alone as sine theta by cos theta. So now, because we have written tan as sine by cos, we have some work further. What? Common denominator. Common denominator is cos theta. So you get cos theta minus sine theta. Cos theta minus sine theta plus this one as it is sine cube theta by sine theta minus cos theta. All right. So next step, this is actually cos square theta. This is the denominator. This is the denominator, children. This is the denominator. So you can do it in your mind. This is cos square theta divided by this. So it'll become reciprocal. No, it will become cos square theta into cos theta. Okay, let me write that step. So this will become, this is cos square theta divided by cos theta minus sine theta by cos theta plus this one as it is, sine cube theta divided by sine theta minus cos theta, as it is. Now this is going to become cos square theta into cos theta divided by cos theta minus sine theta plus sine cube theta by sine theta minus cos theta. So cos square theta into cos theta is cos cube theta by cos theta minus sine theta. There we have sine theta minus cos theta. So change the connecting sign. Plus becomes minus, and we write sine theta minus cos theta as cos theta minus sine theta. I've told you this. If you want to write a minus b as b minus a, do that and change the connecting sign. So sine theta minus cos theta, we write it as cos theta minus sine theta and change the connecting sign. Plus becomes minus. Now common denominator is cos theta minus sine theta. All right, so the numerator will come as it is cos cube theta minus sine cube theta. Now this is like a cubed minus b cubed, a minus b into a square, a minus b into a square that is cos square theta plus ab plus cos theta sine theta plus b square plus sine square theta divided by cos theta minus sine theta divided by cos theta minus sine theta. The numerator is a cubed minus b cubed, which is a minus b cos theta minus sine theta into a square cos square theta plus ab plus b square cos theta sine theta plus sine square theta. So now this gets cancelled. This gets cancelled. So in the second bracket, sine square theta plus cos square theta is 1. You can see that there. Sine square theta plus cos square theta is 1. 1 plus cos theta sine theta or sine theta cos theta, which is the RHS. See here, children, cos square theta plus sine square theta is 1. And the sine theta cos theta, which is the RHS. Please write down. Done, children?
No, ma'am.
All right. Done, children?
Yes, ma'am.
All of us? Yes, ma'am. All right. Okay, so let's finish with some simple ones. So prove that, root of tan squared theta plus cot squared theta. Let me write neatly, 1 minute. Prove that square root of tan square theta plus cot square theta plus 2 is equal to secant theta, cosecant theta. Square root of tan square theta plus cot square theta plus 2 is equal to secant theta, cosecant theta. Yes, children. So LHS square root of tan square theta plus cot square theta plus 2. Now this can be written as tan square theta plus cot square theta plus 2 tan theta cot theta. Tan theta cot theta, because we know that tan theta into cot theta is 1, because we know that what is tan theta into cot theta? What is tan theta into cot theta? Tan theta into cot theta is tan theta into 1 by tan theta, which is 1. Which is 1. So when you write tan theta into cot theta, see, it's actually 2. It's only 2. See, I've written tan square theta plus cot square theta. It's only plus 2. But along with 2, we've written 2 tan theta cot theta. We did not simply write 2. We've written 2 tan theta cot theta. That's okay because it's 2 into 1. It's still 2. Though you see something after 2, it's only 2. Though you see something after 2, it's 2 tan theta cot theta. But you know the product is 1. Tan theta cot theta is 1. So it's the same. It's 2 into 1, which is still 2. Now, why do we do that? Because we complete the identity. We complete the square. Now, this is like a square plus b square plus 2ab. See that? A square tan square theta plus b square cot square theta plus 2ab, 2 tan theta cot theta. So this can be written as tan theta plus cot theta, the whole square. Tan theta plus cot theta, the whole square. And what is tan theta plus cot theta? What is square root of tan theta plus cot theta, the whole square? What is it? What is it? What is square root of a plus b the whole square? What's the answer?
A plus B, ma'am.
A plus b. So what is it here? What is square root of tan theta plus cot theta the whole square?
Tan theta plus cot.
Tan theta plus cot theta. Very good. Is this the RHS? Is this the RHS?
No, ma'am.
No. Then what will you do? We only know one thing. And what is that one thing? Yeah. So write in terms of sine and cos. Sine theta by cos theta plus cos theta by sine theta. And after this, what do you know? We can do only one thing after this. And what is that? What is that?
Common denominator, ma'am.
Common denominator. 1 second. Common denominator. That's all we know. We don't know anything else. So let's do the common denominator. Sine theta, cos theta. So the numerator is going to be? What will be the numerator?
Sine square theta plus cos square theta.
Sine square theta plus cos square theta, which is 1. 1 by sine theta cos theta. 1 by sine theta is cosecant theta, and 1 by, see, this is nothing but 1 by sine theta into 1 by cos theta. Cos theta. Yeah. So 1 by sine theta is cosecant theta and 1 by cos theta is secant theta, which is the RHS. So what's very important here is, in order to complete the square, it's already a perfect square. See, actually, tan square theta plus cot square theta plus 2 is already a perfect square, but it's not convincing. So it's convincing when you write 2 tan theta cot theta. Tan square theta plus cot square theta plus 2 is actually a perfect square, but it's difficult to believe. Because you see a square and b square, where is 2ab? Without 2ab, how can you say it's a perfect square? So when you write it as 2ab, 2 tan theta cot theta, then you believe. 2 tan theta cot theta, yeah, a square plus b square plus 2ab, 2 tan theta cot theta. But they're the same. 2 is the same as 2 tan theta cot theta. Or 2 tan theta cot theta is the same as 2, because tan theta into cot theta is 1. So it's 2 into 1 anyways 2. So a square plus b square plus 2ab is a plus b the whole square. And then you get rid of the square root symbol and you get tan theta plus cot theta. It's not the RHS. So sine by cos, common denominator, and you get it. Please write down. So this is one idea. So you can write, one can be written as secant sine theta cosecant theta. One can be written as cos theta secant theta. Yeah. Done, children?
Yes, ma'am.
All of you?
Yes, ma'am.
All right. So this is where, a sum or a difference becomes a product. We'll see how to, bring a difference or a sum as a product. So see this one. You'll have to prove that tan square theta minus sine square theta is equal to tan square theta sine square theta. Tan square theta sine square theta. So look at this. You'll have to prove that tan square theta minus sine square theta is equal to tan square theta into sine square theta. So whenever you have to do this, take the help of reciprocal ratios. Yeah. Now tell me, children, what shall we do?
1 by cos.
That's one of the ways. Now, supposing we use the usual rule, write tan in terms of sine and cos. Write tan in terms of sine and cos. Tell me like that.
Sine square theta by cos square theta. Minus sine square theta.
Okay.
Common denominator. Sine square theta minus sine square theta cos square theta by cos square theta.
No. No. Rule. There's a rule everywhere. What is the rule, children? What will you do if you have a square by b square minus a square? What will you do first? Think, it's very easy. You want me to say?
Yes, ma'am.
Common. Sine square theta is common. Yes or no?
Yes, ma'am.
That's what. You should use a rule. Sine square theta is common. So 1 by cos square theta minus what? Minus
1.
1. Now what is 1? Yeah, what is 1 by? Now see, according to the situation. According to the situation. Now we got sine square theta. What is 1 by cos square theta? What is 1 by cos square theta?
Secant square theta.
Secant square theta minus 1. And what is secant square theta minus 1?
Tan square theta.
Tan.
Tan square theta, which is the RHS. So you can actually do this in many ways. So this is one of the ways. So tan square theta is sine square theta by cos square theta minus sine square theta as it is. Now the rule is whenever there's something common, bring out the common factor. So sine square theta is common. 1 by cos square theta minus 1. And 1 by cos square theta is secant square theta. Secant square theta minus 1 is tan square theta, which is the RHS. We'll do one more and wind up the session for today, children. Write down first. Yeah. Yes, children, if you have any doubt, please ask me. Yes?
No, ma'am.
Okay. Done, all of you?
Yes, ma'am.
So this one is let's try this. We need to prove that cosecant theta to the power 6 is equal to cot theta to the power 6 plus 3 cot square theta cosecant square theta plus 1. Cosecant theta to the power 6 is equal to cot theta to the power 6 plus 3 cot square theta. Yeah. Yes, children. So the first step is we know that 6 is 2 into 3. 6 is 2 into 3. Now the decision, you have to take as a very important decision. Which one to put outside? Should you write it as cosecant square theta, the whole cubed, or should you write it as cosecant cubed theta, the whole square?
Cosecant square theta to the cube.
Yeah, you should write as cosecant square theta, the whole cubed. Because all our identities have power 2, not 3. So don't write cosecant cubed theta. Write as cosecant square theta, the whole cube. 2 3s are 6. 3 2s are is also 6. But write cosecant square theta, the whole cube. Now you can see the RHS. It has cot in it. There's cosecant and cot. So now the identity. What is cosecant square theta? 1 plus cot square theta. 1 plus cot square theta. Cosecant square theta is 1 plus cot square theta. First we write 6 as 2 into 3. So cosecant square theta, the whole cubed. Now cosecant square theta is 1 plus cot square theta, the whole cube, the power 3 as it is. Now we'll expand using the identity. A plus b the whole cubed is a cubed plus b cubed plus what children plus completed. What is a plus b the whole cubed? A cubed plus b cubed plus
B square.
3a square b. What?
3ab square.
3ab square. 3a square b. What is 3a square b? 3a square. Okay. Yeah, 3a square. 3a square into b plus 3a b square. Yeah. So a plus b the whole cube is a cubed plus b cubed. B is cot square theta. B cubed plus 3a square b plus 3a b square. A is 1 children. A is 1 and b is cot square theta. Okay. So 1 plus cot theta to the power 6 because 2 3s are 6 plus 3 cot square theta plus 3 cot theta to the power 4. Okay. So when you get something like cot theta to the power 4, actually it's scary. Again to the power 4. So what you should do is when you come across something like this which is not relevant to the RHS, you use the other identity 3ab into a plus b. 3ab into a plus b. See, you never know. Only when you work and you check with the RHS, you realize. So now when you work this, when you use a cube plus b cube plus 3a square b plus 3ab square, 3ab square, you get cot theta. You get cot square theta the whole square, which is cot theta to the power 4. So you write it as 3ab into a plus b. 3ab into a plus b. It's very situational. You work it, and when you get the power 4, it's not at all relevant to the RHS. So a cube plus b cube plus 3a square b. Sorry, 3ab. Where should I continue? Yeah, 3ab. So 3 into a into b into a plus b into a plus b. Yeah, so see here, a cubed, 1 cubed plus b cubed. This is b cubed plus 3ab, 3 into a into b into a plus b into 1 plus cot square theta. All right, so 1 plus cot theta to the power 6 plus this one is 3 cot square theta. This one is 3 cot square theta. Now you can see here, we have got almost these terms, cot theta to the power 6 here. 1 is out here. And this is the other term. This is the third term, 3 cot square theta, cosecant square theta. Well, we have 3 cot square theta. So immediately we'll change this to cosecant square theta because 1 plus cot square theta is cosecant square theta. So you need to keep looking at the RHS. You need to keep checking with the RHS. I'll tell you this again. Tell you this one again. See here. One cubed is 1 plus, so 1, it's here. Okay, we're happy. Then cot square theta, the whole cube is cot theta to the power 6. It's here. Okay, so we got these two terms. We need to get this term now. We need to get this term now. Plus 3 cot square theta. We got 3 cot square theta. We need to get cosecant square theta, but here it is 1 plus cot square theta. What is 1 plus cot square theta? Cosecant square theta. So into cosecant square theta, which is the RHS. You can rearrange cot theta to the power 6 plus 3 cot square theta cosecant square theta plus 1, which is the RHS. Yes, children, please write down. That's it for today's session. And children? Finish writing?
Yes, ma'am.
Yes, ma'am.
All right. All right, children. So that's it for today's session. Thank you so much. Good night.
Thank you, ma'am.
Thank you, children. Good night.